Welcome to your Business Calculus lesson 3.4. We're going to talk about graphs and derivatives. Okay, so we're going to build on something that we ended the last presentation with. If a graph is smooth and continuous, the derivative is equal to 0 at the turning point. So whenever the derivative goes from positive to negative or negative to positive. All right, anywhere where a function is decreasing, any interval on which a function is decreasing, the derivative will be negative. And then it has to turn, and the derivative will equal 0 in order to then have an interval where the function increases. The interval where the function increases means that the derivative is going to have a positive value. And then if it turns again and the function decreases, at the turning point, the derivative is 0. And the interval where it's decreasing, the derivative is negative, less than 0. If it turns again at the turning point, the derivative is 0. And then after that, the original function is increasing and the derivative is positive. So how does it look when you look at a function and its derivative together? Well, let's look. Oh, first, though, we're going to reiterate that a function is increasing on an interval for increasing on any interval for which the derivative is positive. So again, here where the derivative is greater than 0, we have our original function is increasing. Here where the derivative is positive, our original function is increasing. A function is decreasing for any interval for which the derivative is negative. So if you know the derivative is negative, then you know the original function is decreasing like it does here and here. Now let's look at a graph and its derivative together. So here we have f of x, and here we have the derivative. Okay, f of x is x cubed minus 4x, so the derivative is 3x squared minus 4. Okay, so we're going to go from left to right on this first interval from negative infinity to what appears to be somewhere right here where the turning point is. On this first interval here, the function is increasing. Okay. Now, on the same interval where the original function is increasing, you'll notice our derivative is positive. Okay, it has positive values. At the turning point right here, the top of the hill, the derivative equals 0. Okay, so when the function turns, the derivative is 0. So from that point, for a while, the function decreases until we get to another turning point. So all on that interval of x values, where the function decreases, the derivative is negative. When we get to the x value where the original function turns, the derivative is equal to 0. The function is going to increase as we go to the right, and the derivative is going to be positive as we go to the right. It's going to take some practice of working with a derivative and being able to sketch what the function's doing, or working with a function and being able to sketch what the derivative is doing, but we need to be able to do that. Okay, guys, so go ahead and do as much of your problem set as you can. You know where to find me if you need some extra help. Thank you so much for watching the video. I hope you have a great day.